So hello again to another session, this time back in the office of ZK Ask the Expert. Today I would like to go a bit into the details of an article I wrote a few weeks ago about cache busting on demand for your static resources to avoid running into caching problems or asking your users to reload your browser cache. Now, this ideally you shouldn't have to ask users, and just show a technique I came across recently that allows this in a convenient way, maybe not the cheapest way, but I think at a feasible overhead. But that's something we can maybe discuss later. Okay, why not just go through the bullet points? So what I would like to do is in the previous session, if you don't know all the existing features, and I had a session around 2 years ago about caching in ZK in general, where we talked about how ZK is doing the caching internally. So today I will just summarize the features we have built into ZK and focus more on the live coding. Just an idea, maybe live coding is also nice for this kind of sessions. And if you need more details, maybe just request the old session that we did earlier, because most of the features haven't changed. There's a small update I mentioned briefly in the next section. As that we implement a small hashing function for resources. Just verify that the results are working and maybe have time for discussions. Okay, let's start with built-in features. So what can we do, or what does ZK do by default? I just start my test application. I go through it in a second when we go to the coding. Right now, I'll just start the application and move the browser into the view. And we just quickly look into what ZK is doing by default. And when I mean ZK or static resources in ZK, I mean the resources that we prefix with a tilde, or more specifically with a tilde dot, which will load resources from class path, which is the ZK internal way to handle resources in general. And yeah, just see what kind of resources or what kind of URLs are created and how we can change them to allow better caching. So by default, you see there, if I reload the page, it will, for example, load this image. I only filtered images right now. I put this filter here to avoid the animation to be showing up in the network tracing here, because it somehow causes a lot of CPU on my system right now. I don't know, maybe it's a bug or something I need to update. So I don't show the progress animation GIF. So don't want to hide anything. It's just if I enable it, you see this animated GIF here, it's making things slow on my PC. So what you want to see is we are loading an image, for example, image ZK logo SVG, and ZK will add this kind of hash code here, or this kind of 32-bit number. I think it's 32-bit number, and this is just the hash for the whole ZK version. So this one will change whenever you update the ZK version, and that's fine for ZK's internal resources. But as soon as you want to load other resources also using the same mechanism, then it's quite bad that this cache or this URL doesn't change. So if we want to change this, there is a flag in ZK which is called org-zcos version UI version info enabled, and it has three possible values: true, false, and anything else. And just open the documentation about it. Here you see you can set it to true. We can set it to false to hide the version information. And if you want to be more obscure, you can put any other value there, and we will somehow sort the hash code, and then it will just generate a different number. So this is something you can use for generating unique URLs. I didn't mention this at all. That's my wrong browser. I need to cut this out again. Why did this one open? I wanted this browser. So what did I say? Sorry, you caught me. It was 5 minutes in. Okay. We have the logo. Yeah, we want to adjust this hash code. Why this is good or bad, I should have mentioned this earlier. But okay, so what the general idea is to keep things simple, we just generate a new URL for changed resources, and that's why we can cache, or where it doesn't matter how the browser caches the URL. If it's cached forever, a new URL has to be fetched again from the server. Just avoiding hassle with cache headers. I just mentioned at the bottom, I should have flipped the order. So that's a way to change this this property. In order to do this, we just go quickly into the ZK XML and we change this to something else. My build 1, my build 2. So whenever you increase this number, you will generate a new salt or a new hash. And whenever you run your application, it will be a different number. So we just mentioned what started with 4, 6, 8, 9, and if we reload, it should be something different now. Come on, load it, load it. I want local host. It takes more time to restart now. Local host. So here we see it's, well, I thought we see. It always happens live. What did I forget? Restart the application. Because any non-null value should produce a different hash. Just reload again. Maybe 4689 FT677. If I set this to true. Okay, last try. If it doesn't work, I will just assume it works at a later state. And reload the thing again. FD67. Okay, that's a mystery. I thought I tested this before. All right, so this one should work. I'm just blind right now. I don't know why it doesn't work. So setting this property should change the version info. Maybe I'm setting it as a runtime property or configuration. Because this, I don't know, it's, just completely threw me off my rail. Enable. Yeah, there's nothing disabling this. If anyone sees what I'm missing, let me know, because I want to go into the live coding. It's just come on. No, it doesn't change today. I don't get it. Okay, that's the plan. It should change this part of the URL somehow. It doesn't right now. I hope the other things I'm planning to show are working today. Okay, so the next, so the idea behind this is this one should be a very effective, a simple way to change this hash code for all URLs. So if you want a complete reload, it will just force the browser to download all the resources coming from the class path. By the way, the class path resources are in the web folder below the class path resources of your application. That's why it's called class web resources. It's a bit brute force. It's inefficient because it will download everything, even if it doesn't change. But between ZK versions, there's normally changes almost everywhere in these resources. So for ZK, it's an efficient way. For us, we want to do something else. We can do a different version for JavaScript modules in the language add-on configured. I won't show this today, but it's possible to have specific version for different modules because ZK has different release cycles for different add-ons. For example, in ZK Google Maps or ZK Editor, they have a specific version here, so you can update one of these add-ons without updating ZK. But it's a bit limited because it's only affecting the JavaScript files. What we could do is we could manually add some kind of URLs, parameters to our URL that we update. It's maybe simple and non-invasive because you don't have to change anything else. But with a larger application, it's hard to maintain. And I've read somewhere, I also mentioned a link in the article that I wrote earlier, that this doesn't work everywhere. Somehow some proxies ignore the question mark parameters and still cache the resource. So need to be careful with this one. And instead, and the last thing I don't want to go into today is really dealing with cache headers and what are they called, e-tags and all this weirdness, trying cache lifetimes. But this is server and browser specific because you have to make sure that no one else is overriding these cache headers or maintaining them. You will get additional requests because the browser will still ask the server, is there an update for the resource? And you get the unchanged responses if there is no change. So it still needs to communicate with the server. I would say good luck. I always try to avoid it if possible. It's, I think, more semantic to have a real unique resource name for unique resources. And that's what we want to go. There's this weird word revving. I read it somewhere. It's just like making URLs unique by adding some kind of revision parameter or some kind of cache busting part in the URL, and can be part of the URL parameter, or ideally can be part of the file path or the file name. As you've seen already, ZK does this by default with its own cache breaking token. It's called this in the path, and we just leverage the existing feature. There's one method you could use, a URL encoder. It's very simple to implement, but you get full control, but you have to deal with every request like this. So every encoded URL at server side will go through this handler, and you have to just manage everything. So if you want, use this one. Today I'm not going to this because it's straightforward to implement, but it's all on your own. And instead we go into something more specific to extend the tilde dot syntax in ZK. So just let's look at our test page. So what we do is we include an image, which is coming from the web image folder from here, the SVG, and using the ZK's default syntax. I also have the prepared example, so just to show what we want to get at, and we want to customize the existing prefix with something by ourselves. In the article, I did an MD5 encoder as an example, and today we use SHA1. It's the same thing, just a different encoding mechanism, and we implement it from ground up. And this will make sure that we get a live computed hash in the URL, and we will improve this in a gradually. So the existing mechanism does this. We have, or allows several things. And we can use this for example, for style sheets. You can use it for script files, which are easy to easily change if you have like patch files that need to immediately change because you need a JavaScript patch somewhere or some kind of additional behavior. It's annoying to ask users to say, use Control F5. Yeah, it should just work. So it would be ideal for these. And I use this, in this example, I heavily use images because they are just better to visualize, and we just see what's happening there. But what we see here, for example, with the script file, it's loading my script version 1. And with the MD5 implementation, you see it's replacing this token that's generated by ZK with our custom token. There is a secret, or I think non-documented prefix we have. It's called _ZV. It's ZK version, and anything after this, this token is ignored, and the URL will just work as before. So it will just find the web resource image and ignore everything here. And we want our hash code in here. The MD5 I just added for debugging purposes, so we can see what it's doing. And if we change a file, for example, our JavaScript file, we say we want a version 2. Wait, one thing. You will notice when I refresh the page, it will reload everything from cache. I didn't disable any of the caches as I usually do during development to simulate the production behavior. Yeah, it will just stick to the version until the URL changes. And if we save this version, ask IntelliJ to update and compile it and reload, we should see that our script version 2 is running. And if this doesn't work now, I will go home. No, we see version 2 is running. And we also see, no, we didn't enable this, but we see here that the updated script was not loaded from cache anymore. It was refetched from the server. And if you refresh, it's loading the cached version of the script. And if we change it again, version 3, it just changes again. Version 3, and it will refetch this file once. And the same will work for style sheets and for images. For example, if we change our logo and make it pink, now we see we changed it to pink. Now we have rebranded our ZK, and they already see what's happening. Our MD5 hashed URL is reloaded from the server. But the original resource using the default mechanism is not, because the ZK version hash didn't update. So that's one of the benefits already. Now, because we changed the URL, we have a new how to say a new URL. We have a new URL, and it can't be cached. And we get the new version immediately. This also works for localized resources. If we have a German version. Now, for example, we make Germany is taken over by Jamaica. We will, I need to compile. It will just load the Jamaican version. So it works for these localized resources. I'll go into this feature in a minute. So that's what we want to achieve. Now let's implement it. For SHA1 hashes. So we don't need all these files. What we want to do is we start with our where do we start? With the SHA1 in it. I just implemented an empty or almost empty web app in it, which is a listener that is called by ZK during application startup. And the first thing we need to do is we need to add, or need to register our new resource prefix. In ZK, it's called extendlet. It's somewhat an extension to the default servlet by ZK. So the ZK AU servlet that handles resources, or the resource servlet, depending on the configuration, can be extended by adding a new extension to it. It can be any string here. Just pick the angle brackets because it looks nice, or it looks similar to what they do in Webpack or other Node.js packaging frameworks, where they add hashes into URLs or into resources. But we don't do this at build time, because these are runtime features at ZK, so we replace this at runtime. Just import our classes we are missing. Extendlet context is doing or can do slightly more. We only want one feature of it, so we don't use this interface directly because it has too many methods. I don't want to override all these, makes things a bit ugly. Instead, I have prepared an empty implementation that throws unsupported operations everywhere that we didn't implement, and we only implement the encode. Where is the we don't implement here in this interface the encode URL method, so we only have one method left to override. So we can say new resource URL encoder and implement just one method. Now the other ones have a default implementation. We just use this one. And because we don't like this, we just move it to the outer scope, so we don't have to restart too often in the future, and just cast directly. It's just something I will do once, and we say we want the method reference this encode URL. Okay, so now we have our inline, or we have added our extended context, and we can do something here. My plan to show this is to start with so we simplify the interface, and we make a dummy implementation that will just hard code our URL parts that we need. So we just read it, we just generate URLs, just go to the original servlet. So we say return, the default is ZKAU. This is configurable, so we use something else later. It will have the web prefix, and we will add the URI that we get in here, the resource URI. So that's the easiest way to encode this ourselves. So if we, usually I forget something, we just try, recompile and restart. And then we should run to this method, and I'm sure I did something wrong, but now we should be able to yeah, and we use our new test page, just the same thing. We start with an image, we add another image, separator, and we want to use our registered prefix, SHA-1, and save it. And here is our initializer, which will register to this prefix. And if we are lucky, we can, I will just go to the page I prepared. If we're lucky, we see the logo twice. And what we see in the network trace is that we have one with a cache token in the middle of ZK and one without anything. So if we cache this image, which it already is, it will never change the URL. So we need to add something in between that ZK will, or the browser will get a unique URL for this element. So what we need to do is add something here, add some magic here. We add the hash here. And our hash will be, just do something standard. As I said, there's a prefix that we need to add to have a token that ZK will safely ignore. It's only for the browser to have a unique URL and the hash. Well, the hash. And this is what we will compute. And I have too many pluses here. Okay, let's see. We should have this in the URL now. Yeah, the hash is here. Because I used the same thing during my practice earlier, it's already cached. So if we were to change this, and we should change this later, we will get a new URL and something that is no longer coming from cache. So it's still the old one, and reload. Forgot to compile. Okay, and reload. And here now it's the hash 2. Already see it's using the updated version that we had previously, the purple logo. We just undo this. No, wait, also compile this one. So that's the basics. Huh? We have a hash. We just need a method to generate our hash. And to generate the hash, that's the second part. We have to somehow find the actual file. Huh? So we can compute. We can go over the binary data and compute the contents, the content hash. Use some Java API to compute a hash code and encode it to be URL safe. We use base64 here. We use the message digester in Java, and here we find the default extended context in ZK that we want to reuse because we want to leverage the existing features of ZK. We don't want to hard code everything here. So what we do is we prepare our extended context. Get extended context. The default one is, as we've seen earlier, just the dot. And this is something we just assign to a field. How to do this? Var. And then Control-Shift-F. Okay. And we call this CWR for class web resource. And that's ZK's standard thing. We assign it to a field. And then we have this available in all the other functions. And we make a method that generates our hash. So we say Control-Shift-M, compute hash. And what we need to pass in is the URI. Add string as first parameter. Okay, now we replace this hard-coded value with the actual hash code. So as we already said, I just recompile and restart the server. And now we can just implement this stuff. We need the original resource. We said we want the ask the class web resource, the original implementation, to just give us the actual resource. There's a method get resource stream, which is locating any kind of ZK class web resource in the class web folder. And we just use the URI we are getting here. So that's what ZK does by default. And we assign this to a variable input stream. And we need to wrap this in a in our MD5 hash. So we create a thing called message digest, get instance, and we want the hash mechanism SHA-1. It will need some how to say exception handling. We just ignore this for now. Add exceptions around. Okay. And we create the real input stream. We'll just handle every exception here and just throw runtime exception. So we don't have to deal with it right now. Throw no runtime exception E. So we know whenever something went wrong, we get an exception somewhere. We can handle it globally in ZK's exception handler somewhere. Not the topic today. And we wrap it into a message. No, a digest input stream, I think, if I remember right. Digest input stream, yes. And we create a new one of the input stream and using the message digest. Just inline this here. So that's the input stream we want. We just inline something here, inline the variable, so it's nice one-liner, which we can use in our try with catch block. So we don't have to close the stream. We can't forget to close it. It's always tedious working with input streams and forgetting to close things. So we just use Java's built-in try with catch mechanism. Just say input stream equals, and just move all this before the try block. So we are guaranteed that this input stream didn't fail creating, and we can use it inside our function, or inside the try block. So we just say is dot, and what we need to do is we need to just go over the content once, so that this digest input stream will compute the hash. So we just transfer it to nothing. It's a bit of a waste. That's the overhead we have. We just iterate over the content once and throw away the results. And while it's iterating, or while it's streaming over all the binary data, it will produce the output stream in the the hash code in the end. So we can say we return the is dot, and now we can get the message digest, and we call digest. That's the byte sequence. And we want to encode this as base 64. So we use the base 64 utility, and we use a URL safe encoder, which uses characters that are URL safe. And we also say without padding, because I don't know if the equal signs in the end are useful, so I always remove them. And then we encode to string, and we pass in our bytes. Yeah, that's it. So now we have a method that will produce our SHA1 hash code, hopefully. Let's see if we can test this. Control-Shift-9. So it's recompiling. It looks a bit shorter than my previous examples. I'm sure I missed something. We will find out. So we reload, and now, yeah, I forgot something. Okay. Now we see we have a code, a hashed result here, but somehow the URL is broken. So I forgot to add something. So we need, of course, the _z version in front of everything. And just try again. And come on, did you finish compiling? Yeah, now we have the logo, and we have a nicely hashed URL. If we refresh it, it will, if we hard reload with Control F5, it will download the resource once. And if we reload again, it will be in the cache. Now we have a URL that is unique for this content. And whenever we change whenever we change the content, we have a new URL. Just try this. So we said we have our logo here, and we make it, well, pink is always. I'll just use a different pink today, so we know it's not something I cached earlier during my tests. And we reload it, and we see it's generating a new URL. Even though the top logo using ZK's building mechanism should return the same result, it's still having the old cached version. If we force a reload, it will also update. But that's something, I said, we want to avoid. So that would be it if it weren't inefficient. And we also have these hard-coded parts here we want to get rid of. So what we do now is we reuse some of ZK's existing features. And also we re-enable our localized version, the German version. If we try this now, if we just add the German version, which is, by the way, just adding a star in the name. This is special ZK syntax. When the URL starts with a tilde dot, you can use one star, and the first star is for the locale. The second star is for browser-specific URLs. If you need maybe a mobile version of an image, or a macOS specific version, of Safari specific version for the browser, there are ways to have resources that are returned based on the user agent string. But if we try this now, we get a nice null pointer exception, or I don't know what we get. I just said it can't encode the hash at the star because it doesn't find the resource, because right now we don't use any mechanism to replace the star with the current user's locale. And to do so, we also reuse the existing functionality on our CWR extendlet. So we just make sure we've used the correct URL. I always forget what this was. And servlets locate. Okay, so we say servlets.locate is the function to get the current resource. We say we want the servlet context. I forgot to make this a variable, a field. Servlet context. Okay, Shift F9. Okay, so we want the servlet context, comma. We pass in, I think it's the request. Sorry, it's jumping a bit around. The request. The next parameter is it says page path, but it's the resource path. So we just use the URI and the locator. I forgot which one the locator was. I need to sneak into my previous example. I forgot what was the locator. Ah, yeah, of course, it's the default locator of the default extendlet context. So context.getLocator. IntelliJ already knows what I need. And we just assign this to the same variable, and we just override it with the updated version or the updated file path. I'll put a breakpoint here just to see if we get what we need. And we reload the browser today. Reload. Oh, my CPUs. Ah, the server didn't start because of compiler errors in the meantime. Okay. And whenever I add a new private field, I have to restart the server, even with the hot code replacement, because this init method only is executed during the application startup. So I have to force a new application startup to call this method to populate my instance variables. Once they're there, we can just change the contents directly. So we reload again, and now we reach our breakpoint. The first thing is a URL without the star. We have seen this already. And now we have a star. Yeah. Whenever we encode this, when we call the original functionality, it will hopefully find our German version of this resource, F8. And it did. So it's checking if there is a localized version. If there was no DE_DE, it would fall back to the DE version. Or if I'm having the Swiss locale DE_CH, it would use the fallback DE version. And this also works for scripts, for CSS files, even for Zool files if you have different Zool includes. But these are not static resources. Zool files are anyway dynamic, so caching is pointless there. Yeah, so we know this works, and now we should get a result in the browser we even have the Jamaica version of the German flag. Control F5. So now everything is reloading, and if we switch back to the real German flag, here the German version, just make it red again. We should get our German flag back. But as you are, I tried this earlier, that's why it's still cached here. But the URL changed, and it found the old URL that was already there. So if you change your resource and you accidentally get back to a state that you had in the past, you can still safely use the old cached version. It's not a bug. That's even a feature because the resource content is identical and the URL is identical. So this just means we can cache our URLs forever because a new resource is just a new URL. That's the best caching you can do. Caching forever is never have a problem. Just drink something. Okay, now we used now we enabled ZK's feature to how to say, to use the localization or the international version of the resource. We still use the same computation and we return everything, the whole URL, but we want to get rid of the hard-coded bits here. So the next part is we replace the ZK version token, and in order to do so, we just get the original encoding prefix on the utility class CWR. I think it's called class web resource, which we can get from the web manager. That's things that you don't accidentally come across. That's stuff I find out for you. So we say web manager dot get web manager for the current web app, and we say get class web resource assigned to variable, and we just call it CWR because I like this better. And we also make this a field. Okay, then we need to restart, and now we can use it in our encode URL function to get rid of this. So what we do is we call the original encoding mechanism of the original extended context. So we say CWR extended context dot encode URL. So we just do what ZK would do by default. So it's no additional overhead. It's just something we reuse. Response and the URI. So this is the located version, and we assign this to a variable. How to do this? Dot var, and we call it encoded URL. So this is the default encoded URL. It will contain ZK au/web/ZK hash token, which we just want to replace with our token. So we want to replace this. So we say encoded URL, and we want to replace the ZK extension. So CWR dot get encode URL prefix. That's the hash code that ZK computes for the current version, and we replace it with our hash. And to do it correct, we prefix it with I think it's ZV. I forgot if we need the slash or not, so just go with the slash for now and then try to fix it later. So it's recompiled. Let's hope we get the same URL again. And yeah, looks like we didn't break anything. Just make this a bit more visible. We assign, or we extract another variable replaced, so we can put a breakpoint and check what we did. Breakpoint should activate in a second. Okay, and if we reload, we can see we get our encoded URL, which contains ZK's token, and the replaced URL contains our SHA-1 SHA-1 hash. Okay, things are working nicely. How much time? 15 minutes. That's perfect. So a small enhancement we can do is just measure how long does it take to compute all these hashes. Just make this quick. Today we just output the milliseconds before and after. So we say long start equals system point nanotime, and after our hash encoding, because this is ZK does by default. We don't measure it. Just want to see what we do. Oh, we can include it. Doesn't matter. And we say long end equals system dot nano times, and then we just output the difference as out. And we say just output the nanoseconds. So and minus start. And nanoseconds are hard to understand, so we just convert them to milliseconds. Time unit dot nanoseconds, and we say to milliseconds, and we just convert the difference into milliseconds immediately. And now we should see some time it takes to compute this. Could be great because my CPU is busy, so it should be really bad. Or we should see a worst case. In the console, 5 and 1, so not a lot. 5 milliseconds for the first one, 1 for the other one. I think it's just noise. I see 0, 1, so it's less than a millisecond for this tiny resource. If we try a larger image, this one is, I think, about 1.2 megabytes. We will see this in the browser. We can see how long this one takes. So we just say we want the large image, large image.jpg. That could be a large background image that you have in your application. And we also want to cache those. Here we see 1.2 megabytes. And how long did this one take? 81 milliseconds. Just reload the browser a few times to see if this is maybe getting faster. If we try this again, 57, 9, 26. So it seems to be, it seems to have some overhead, but it's not a lot. So if we do this, or if we somehow implement our initializer, our hashing function to never evaluate the same URL twice, we have a one-time overhead for the first person who is downloading this resource. And let's just put them into a cache, into a hash map or something to reuse this. I already did this in the MD5 example. Not enough time to go into this detail now. But what I did here is I put the hash by URI into a cache, into concurrent hash map. So if multiple servlets are accessing this one, there won't be any concurrent error exceptions. In the worst case, 2 threads will compute the same resource and put the same resource a hash in the map. Yeah, this is unlikely, but maybe happens from time to time. It doesn't cause problems. And what I do here is, if the cache is enabled, I just put this into the hash if it's not there yet. I just put the URI here. This is my pre-built implementation. Put it into a cache, and otherwise it will read it. This compute if absent function is a default hash map function in Java since Java 8, I think, and it allows you to compute the value of a key on demand. If the key is not yet in the hash map, it will call this kind of method in the end to produce the key. I think it's a function, and if the key already exists in the map, it just returns it without recomputing it again. That's an easy way to implement a cache. Not enough time right now. Yeah, so this is one of the improvements we can do. So let's go. What did we do? So we measured the time. Time is okay. If we do this only once, I think it's not too bad. What we can do is we can cache the hash results to improve this I already provide an example, and we can also cache these forever at server side, because when we don't change resources at runtime, if we always deploy a new version when something changes, it will just cache these things once for the runtime of this WAR file, and whenever we reload the WAR file, it will start with an empty cache again. Of course, if you had dynamic resources, you could invalidate the cache at whatever intervals you need, or I don't know. Yeah, there are ways to update the cache at runtime, but it's something we don't really want. Another feature we might have, what we could do is via configuration, we could make this string of the hashing function configurable. We can disable this during development. Would be nice to, or disable the cache during development, because during development we don't want the same URL over and over again. That's also something I did in the previous implementation, that I'm loading a library property, a ZK configuration variable that can be set via can be set in the ZK XML. It can be set from command line as a version parameter in ZK. It can be set from Java code just by set property. So there's a way to disable the cache for development. And then you get, like we see here, the updated MD5 or SHA1 hash every time you call the resource. Easier for debugging, and for production, as said, it's safe to have a simple hash map that contains these values. And they don't grow a lot because these hashes are quite small. Even if the resource is really, really huge, we only cache the URL and the hash code, and not the content itself. So I would do this unbounded, and I assume your application doesn't have millions or a dynamic number of static resources. And that's why we use this for static resources. What are other ideas about this? We could theoretically pre-hash known or common resources at application start time, potentially at build time, but then you need to hash all the localized versions, if you have any, manually, and just create a content hash for this URL, put it into your hash map before starting the application, or during startup, or during build time. That's up to you. But I think the overhead is not too bad. Limitations are a bit small, but I think you can't use these for WPD and WCS bundles, because these are dynamic resources that can change due to configuration. This could be something or this is something that is dealt with by ZK, because WPDs are by default the ZK's own resources that change with the ZK version. So you shouldn't have these change. If you have custom bundles, you can use the language add-on to change the version for a new version of these. But maybe it would be nice if ZK had this all the way. So maybe a feature, let us know if this would be something interesting. WCS, ZK's CSS bundles, also rarely used by custom implementations. And right now, of course, this only applies to ZK's static resources or class web resources, as we see in the web, in the class paths, in the web package. If you have resources in your web app folder, in your image folder, this is not treated by ZK at all. There you can go freestyle anyway and implement any kind of resource servlet or redirect to a CDN network, or wherever you load your own static resources. The benefit of these class web resources, I think, is you can bundle them in jar files. So you can have different modules of your application that bring all the resources. So you don't have to copy them to a special resource server. They can be just part of the WAR file. Yeah, I think that's nice. And we have 5 minutes left. So I haven't heard any questions so far. I assume I was speaking too fast, so no one had the time to interfere. So now it's the time. Do you have any ideas or questions about this approach? Is it interesting, or maybe it's useless? As this time was an idea about live coding. Is it useful to have these kind of sessions where we start building some code from zero? Haven't done this before. I always prepared everything. This time we just build it up. I will obviously share the code before and after the session, so don't worry about this. And I don't understand why the default didn't work. Why this one didn't work. It's strange. Your questions are already answered. That's cool. I didn't even know what you would ask. Thanks for letting me know. That's a really strange part that this one doesn't work. Maybe I go slightly into the project. I haven't told you what the project structure is like today. I didn't use any fancy runner. I just used, because I didn't have much time to prepare, I used the default Maven plugin from Jetty. I just run the whole project with Jetty 10, the latest version. Jetty 11 would be the Jakarta version. Jetty 10 is the old Servlet API version. And the same Maven Jetty run command I just launched from the IDE with the extra parameters. In the runner config, it says I disable my MD5 cache by default. So during development, it doesn't apply the hash cache, so it will recompute the same hash code over and over again. And I enable the hot swap agent for the JDK. I'm using the DC EVM, also covered in a previous talk we had about efficient development, where I introduced how to use this special virtual machine that allows the hot code replacement. So I didn't have to restart in many cases today. I had to restart a bit more than I had to because it's initializing code. So I would have liked to restart less often. But as soon as you have all the methods and the global variables and your instance variables set up, you can mostly change the code without restarting. And it's really just the Maven command, Maven Jetty run, nothing else. So if you want to run this project, simple. Also mentioned in the training notes, it has all the run commands here. Maven Jetty run or call from the IDE. Okay, any other remarks? The first time I'm not taking too much time. I'm sure I missed something you might be interested in. By the way, this is not a feature of ZK. This is just the example, just to see if this is something useful. If we have lots of requests, maybe that's worth considering as a ZK feature by default, because I could imagine it's useful. Just let us know. But otherwise, the APIs are public. They are available in ZK CE version. So everything I'm using here is ZK CE, so it's available everywhere. It's just, as you see, a lot of dense code that needs extra explanation, where the stuff is coming from and what it means. Okay, then. I'll just say, yeah, thanks for joining in today. Nice to have you every time. If you have ideas for another training, let us know. And they will always be next month. And we talk about something else. Maybe next time it's the release of ZK 9.6, which should be released next week. And 9.6, yeah, we'll have both I already introduced last time, the Jakarta edition and the default edition of ZK. So it's the first ZK version you can test on both, I would say, both servlet namespaces. Okay, well, I'll stop the sharing. If you have some comments, drop them in the chat. And yeah, we will see you maybe next time.